Okay, Assalamualaikum warahmatullahi wabarakatuh. So we continue our class. This is for the second part. Since I have something come up, so I need to do the asynchronous class. So, but I think the third section we will continue when we have a synchronous class later, meaning that we try to program MATLAB coding to solve the common dispatch. But today, at this section, we try to solve your tutorial. Let's take your tutorial. So in order to make sure that you can understand what is in general in this class, what is we use GA to solve the uh, Chrome dispatch problem. So let's take a look at the example. This is a past, I think 2018 final or test, if not mistaken. So let's say we try to look at the question number 6 and then move to question number 5. Okay, so number 6 is the binary GA. Okay, number 5 is continuous GA. So this is example. So let's do it together. So GA is used to solve economic dispatch problem for 3 thermogenerators. Suppose 2 chromosomes have been selected for mating. Okay, and then 1 point crossover is adopted for each variables as shown in figure 3. So we have figure here. Okay, and then the fuel function in measure per hour of these 3 thermogenerators are as follows. So basically, when you learn about economic dispatch in the undergrad, you know that the cost functions for each generators is in terms of quadratics, right? So this one is alpha, this one is beta, this one is gamma. This one alpha 2, beta 2, gamma 2. And then this one alpha 3, beta 3, gamma 3. So this is just a coefficients of the generations. And if you notice that the representation here, we have P1 and P2 in megawatts. And then you have P1, the output are subject to following limits. So we have limits inequality constraint for P1 between 10 megawatts to 150 megawatts. P2 and P3 between 50 megawatts to 150 megawatts. Okay, and then we have real power loss calculation. But when we do the real economic dispatch problem, basically we will include everything. But this one is because of it's quite troublesome because sometimes we need to apply for the penalty functions. So for the examination purpose, so we just the question is just will be tuned in order to make sure that to test whether you understand or not. Okay, so we have 3 functions, f1, f2, f3, and then we have p1 and p2, p3. So as we can see here that our p loss, normally when we do the programming, we use the Cron's formula, or we use the load flow solution to get the loss. But for this purpose of examination, we have the simplest forms of loss coefficients. So we have P loss equal to 0.001 P1 square, P2 square. And we can see here that our P3 is we treated as a slack bus, slack generator. Okay, and then the representation, because this is a part of the solution, it's not the actual solution, it's a part of solution. So you can see that our representation here in binary. So 1100, 0110, this one for the P1, this one for P2. This one for the chromosome number 1, this one chromosome number 2. And then what happened here is we have 1 point crossover, meaning that these two will be at here, we swap into here, okay, and then to get the new offspring. So let's take a look at the question. What is total cost f1, f2, f3 for the integration function of selected chromosome? So let's say we have the question is number A is we want to find the when we select the chromosome 1, what is the cost function? When we select the chromosome 2, what is the cost function? Okay, so we have P1, P2. So let's take a look at this solution first. So we have 1100. We have 4 bits here, right? So we have 4 bits. So what you can do is, because your is to the power of n, right? So 2, 1, 0, 1, 2, 3. So meaning that this representation for P1 basically is you need to encode, you need to decode, because you have 1, 1, 0, 0. So in decimal is how much? You can use binary calculator in, or you can remember way back in your class last time how you want to calculate binary to decimal. Okay, so since we have in for this web, so we have 1100, we just convert to decimal, it's 12, right? So 12. So in decimal is 12. So how we can get the value of P1? So we have 12 times, because we have how many bits? We have 4 bits. The maximum is what? 15, right? So the minimum is 0, 0, 0, 0. Remember, 0, 0, 0, 0. This is, when we look at the P1, is 10. Meaning that when we have representation of 0, 0, 0, 0 is 10 megawatts. And then we have 1, 1, 1, 1, 1 is the maximum, right? So 1, 1, 1, 1 is the maximum value. So the maximum value is 150. Okay. So now our solution is 1, 1, 0, 0. So this one is 0. This one is how? 15, right? 15. 1, 1, 1, 1 in decimal is 15. So 12 over 15 times the maximum minus minimum plus minimum. So maximum is 150 minus 10 plus minimum is 10. So we get 12 divided by 15 times 140 plus 10. So the value is 122 megawatts. See, that is how we calculate based on our bits selection. So similar for P2, for this P2, P2 is 0110, basically is what? I think now 6, right? Or if you want to double confirm, wait, 6. Okay, so the result is 6 in decimal. So to get the value now is 6 divided by 15, because the maximum is 15. You put 1111 is 15. 1111 convert to 15. Okay, so times this one for P2, your range is 150 and 15. So 150 minus 15 plus 15. Okay, so we get how much? 115, 150 minus 15, 115 minus 15 times 6 divided by 15 plus 15. So the value is 69. Okay, now we have P1 and we have P2. So how much is our P3? So if you remember that we have equality constraints, all the summation P1 plus P2 plus P3 must be equals to your demand plus loss. P loss. So our demand is how much? Our demand 300. So this one is 300. So what we need to do is we need to calculate our P loss based on the P1 and P2 that we have taken. So we know P1, we know P2, so we can put here P1 and P2. Right. So we calculate P3. So our P3 is equals to P demand plus P loss minus P1 minus P2. Okay, so P1 You need to calculate your P loss. How much your P loss now? Your P loss is P1 square. Now your P1 is 122 times 122 square times 0.0001 is 1.4884 plus your P2 is 69 square times 0.0001. So you get 0.4761. Okay, at 1.4884, you get your loss is 1.9. So your demand plus loss is 301.9645 minus your P1 and P2, 122 minus 69. So you get your P3. See? So minus 122 minus 69. So you get your value for P3 is P3 is 110.9645. Okay, so that is your results. So now you obtain your P1, this one, your P3. You have P3, you have P1, you have P2. So you have everything. So to answer the question, part of the question for C total is for this chromosome number 1, you need to put this value into these equations. Put into the cost function, you add everything. So you get your cost. F1 plus F2 plus F2. Okay, so that is for the chromosome number 1. And then for the chromosome number 2 is similar, you just replicate back what you have done. 1010 is what is 10. 10 divided by 15 times 150 minus 10 plus 10, you get something value. Okay, and then similar with the P2 also, 1000 is what? 8, right? So 8 divided by 15 times maximum minus minimum plus minimum. Next, you can get your, before you can get your P3, you need to put these two values into the loss equation to get loss, then you get your P3. Once you get your P1, P2, P3, put all into this equation to get your cost for the chromosome number 2. So that is answering the question A. Okay, so that is the question A. So what about the question B? Question B, calculate for the new generated offspring. So meaning that you need to create your offspring. Offspring number 1 is what? Because since this value, this 1 point crossover is put here, so meaning that your P1 is maintained, right? So your chromosome maintained 1100, but here is 01, this value 10. See, 10. So seems that it will not become a problem there, right? So meaning that the question answering number 1 and 2 is similar because this was one crossover. So we put this one. Okay, this one 1010. So it's meaning that question number B is similar with the A. You can get the value for. Meaning that the parents as well as the offspring get the similar results. Okay, this is just trick question. So student when we are answering the test, betul ke ni kan sebab 1 point crossover because this thing you put here and then this thing you put here back, swapping should be no problem. That is answering for the question B. And the question C, if the mutation is imposed at the bit number 3 variable P2 for one of the offspring. So this one you need to select one. Okay, let's say we select chromosome number 2 at the P2, this one is P2. Variable number 3 have imposed the mutation 0, 1. you have 4 bit, 1, 2, 3, 4, right? So bit number 3, you change to 0 to 1. In that you get 1, 1, 0, 0. So again, you need to calculate how much the value of P2 by using similar equation. So that is how we the answering the question of this particular examples. Okay, that is for the binary. Binary. So let's take a look at the continuous. So the question number 5 is continuous. So continuous GA is used to solve economic disparate for three thermal generators. I think the equation is similar. But your P1, P2, P3, we have this minimum and maximum similar. And then you have P loss, P2 square, P3 square, meaning that your P1 is your slab generator. Okay. Suppose two chromosomes we have been selected. So let's say you have mom, P2, P3, P2, P3. So we have 0 0.75, 0 0.8, 0 0.88, 0 0.22. So we do the combination of extrapolation and crossover that we have learned in the previous section just now. And then this is the equation. So alpha 2, beta 0.55, you get the new offsprings. So again, it is just a similar problem, but the representation now is in terms of continuous number. So what we need to do, so again we need to do the so let's say we try to evaluate mom chromosome. So this one is P1, P2, right? P1, P2. Okay, because no, P2, P3, because our P1 now is the slab generator. P2, P3. So 0.75. So what we need to do is 0.75 times the maximum value is 150. Because this is the floating numbers, this is just direct. We need to divide by each. So you just divide by 1, right? Maximum minus minimum, 1 minus 0 is 1. Okay, times 150 minus 10, 150 minus 10 plus 10. So you get your P2 is 150 minus 10 times 0.75 plus 10. So you get 150. The result is 115 megawatts. So this one P2. And you calculate for P3. Your P3 is 0.8. So 0.8 similar. Since we have the similar boundaries, 140 plus 10. So you get 0.8 times 140 plus 10. So you get 122. 122 megawatts. Again, to calculate the cost, you must calculate your P1 first, right? Because the P1 is slack bus. So we need to put these two values into this equation, you get loss. So to calculate P1, P1 equals to P demand plus P loss minus P2 minus P3, equality constraint, right? So P demand is what? P demand, we have our demand, I think, 270. So your demand is 270. So now you need to calculate your P loss. Your P loss is how much? 115 square times 0.0001. So 1.3225 plus P3 is 122. 122 square times 0.0001. 1.4884. So you get how much? Your loss plus 2225. Your loss is now is 2.8109. So minus 115 minus 122. So you got your P1 how much? P1 is 270 plus 2.8109 minus 115 minus 122. So get your value for P1 is 35.8109. So it's still within the boundaries, 35. And then what next you need to do is you put everything P1, P2, P3 into this equation, calculate the cost. F1 plus F2 plus F3. Okay, so and then you repeat. This one repeat again for that. Just repeat everything. Now it's 0.8, 0.22. Repeat everything. You get P1, P2, P3 for the cost. Okay, next, the B question number B is you need to evaluate for the offspring. Similar, so meaning that you need to calculate your P new, your offspring. P new is P mum alpha, meaning that your alpha number 2 is P mum alpha number 2, this one, minus beta. Beta is 0.55. P mum alpha minus PD alpha. So this is alpha you number 2. Okay. So meaning that 0.8. So to get the P new is P mum is 0.75 minus beta 0.55. P mum is 0.75 minus P dat 0.88. So how much? You can get new value for P new. So you get 0.75 minus 0.88 negative, right, times 0.55. Okay, so 0.75 minus 0.88 times minus 0.5 or 0.55. You get minus become positive, so 0.75 plus 0.0. So you get your value is how much? Minus 0.7. You get the value for P new is 0.8215. Okay, so and then the one PD 3, you just put P 0.22, meaning that this is offspring number 1. Offspring number 2, offspring number 2, P new 2. So P new 2 is P ma alpha, meaning that this value also 0.75, but now it's plus, right? Plus 0.55. This one is similar, meaning that 0.75 minus 0.88. Okay, so 0.75 minus 0.88 times 0.55 plus 0.75. So you get this value for P new 2 is 0.6785. Then P mum is 0.8. So this is offspring number 2. This one is offspring number 1. And then you replicate that. You do that. You do again calculation. You do evaluation by decode this value. You get the P2, you get the P3, and then you get the loss, and then you get the P1, and put everything into this equation and calculate the cost. Okay. And then question C is similar with the previous example for the binary, but now you just use mutation and then calculate again the cost. So that is what we do for this example. So, okay, hopefully you can understand how this one is in terms of examination. It's quite slightly different for when we do the coding. Because when we do the coding, we enforce the penalty function because every P1, P2, P3 we encode. But in terms of final or test examination, I need to tune the question in order to make sure that you can understand. So this one is for your how you decode and how you evaluate the results. Okay, I think that's all for today. So hopefully you can understand. So for the third section, we will do for the next class. We do the synchronous class. Okay, I think that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.